Hello students, I am your science teacher Preeti ma'am and I am going to teach you chapter number 1, matter in our surroundings. And this is our fourth lecture today. Earlier I have completed many of the parts of the syllabus in the part 1, 2 and 3. And in the fourth lecture I am going to teach you the effects of change of pressure, evaporation, factors affecting evaporation, cooling caused by evaporation, and to show the presence of water vapor in air, and two more states of matter, that is the plasma, Bose-Einstein condensate, because total there are 5 states of matter, and earlier we have studied the 3 states of matter. The rest of the 2 states of matter we will study soon. Effect of change of pressure. The physical state of matter can also be changed by changing the pressure. In other words, the physical state of matter can also be changed by increasing the pressure or decreasing the pressure. For example, gases can be changed into liquids by increasing the pressure, accompanied by lowering of temperature, and some solids like solid carbon dioxide can change into gases on decreasing the pressure. So let us discuss it in a little more detail now. Gases can be liquefied by applying the pressure and lowering the temperature. When the high pressure is applied to a gas, it gets compressed into smaller volume and we also lower the temperature. It gets liquefied. So we can also say that gases can be liquefied or turned into liquids by compression and by cooling. There is lot of space between the particles of matter, the particles of the gases. We can reduce the spaces or the distances between the particles of the gases by enclosing it in a cylinder and compressing it by pushing in a piston. And if enough force is applied to the piston, the gas is highly compressed into very smaller volume, and the particles of the gases get so close together that they start attracting each other sufficiently and they form into a liquid. And we can say that gases has liquefied. When the gas is compressed too much, then the heat is produced due to compression. And so while applying pressure to liquefy the gases, it is necessary to cool them to take away the heat produced during the compression. Cooling lowers of the temperature of the compressed gas and helps in liquefying it. From this discussion, we can conclude that gases can be liquefied by applying the pressure and lowering the temperature. So in other words, gases can be liquefied by compression and cooling. A gas must be lowered below a certain temperature before liquefaction by pressure. Cooling is usually done by pouring water over the coils carrying the compressed gases, and ammonia gas can be liquefied by applying high pressure and lowering the temperature. Ammonia gas can be liquefied by the compression and the cooling. Students, oxygen gas can also be liquefied by applying high pressure and lowering the temperature, means by cooling. And liquid oxygen, which is prepared by this method, is blue in color. Students, we have just now studied that increasing the pressure and lowering the temperature can change the state of matter from a gas to a liquid. Even decreasing the pressure and raising the temperature can change the state of matter. This will become clear if I give you one example. Solid carbon dioxide or dry ice is stored under high pressure. This is because on decreasing the pressure on solid carbon dioxide, it gets converted directly into carbon dioxide gas. For example, when a slab of solid carbon dioxide is kept exposed to air, then the pressure on it is reduced to normal atmospheric pressure, means 1 atmosphere. Its temperature rises and it starts changing into carbon dioxide gas. Thus, the conversion of a solid carbon dioxide into carbon dioxide gas is the change of state in which is caused by the decrease in pressure and high atmospheric temperature. Solid carbon dioxide gas is a white solid which is also called as dry ice. So, solid carbon dioxide is an extremely cold substance. It is used to deep freeze food and to keep ice creams cold also. Since solid carbon dioxide directly changes into carbon dioxide gas, or we can say that it sublimes and does not melt to produce a liquid like in the ordinary ice, it is called as the dry ice. Dry ice can produce much lower temperatures than that produced by ordinary ice. So it is much more effective for cooling purposes than ordinary ice. Students, you can see over here is a picture of what happens when we apply high pressure. You can see over here in this figure, the first figure, that the gas particles are there in a cylinder, and this is the piston which is there, and when we push the piston inside this way, then we can see that the gas, it gets compressed and it gets cooled. And when it gets cooled, then you can see over here the gas particles, they come much closer to each other. There is a force of attraction between them. And if we still apply pressure on this piston again, then again compression and cooling takes place. And when compression and cooling takes place, you can see over here the particles, they get so close to each other that the gas, it liquefies. Now let us discuss, students, about the evaporation. Students, when a liquid is left exposed to air, its volume decreases gradually. And why is this so? This is simple. This is because of evaporation. In this process, some of the liquid at the surface on the top layer turns into vapor or a gas and mixes with the gases in the air. So we can say that when a liquid turns into vapor or a gas, it is said to evaporate. So we can define evaporation as the process of liquid changing into vapor below its boiling point. It is called as evaporation. Evaporation of a liquid can take place even at room temperature. Although it is faster at higher temperatures, but at room temperature also evaporation can take place. Whatever be the temperature at which evaporation takes place, the latent heat of vaporization must be supplied whenever a liquid changes into vapor or a gas. You know, students, the wet clothes dry due to evaporation of water which is present in them. And rainwater puddles which are there in this season, you can see over here, as it also dries up because of the evaporation of the water. Common salt is also recovered from seawater by the process of evaporation. So the process of evaporation, I can explain you something like this. Students, some particles of which are present in the liquid always have more kinetic energy than the others. So even when a liquid is well below the boiling point, some of the particles have enough energy to break the forces of attraction between the particles and to escape from the surface of the liquid in the form of vapor or a gas. Thus, the fast moving particles or the molecules of the liquid are consequently and constantly escaping from the liquid to form vapor or a gas. Students, there are some factors which affect the evaporation. The rate of evaporation of a liquid depends on the following things, the following factors. They are the temperature, the surface area, the humidity, and also the wind speed. So let us discuss each of these factors in detail. You can see over here, this is the process of evaporation which is going on over here. This is a picture which shows you the evaporation of the water which is going on over here, as you can see from the surface of the pond. This evaporation, it is caused due to the heat of the sun. This figure that you can see over here is a man who is taking out the common salt, and you know that this common salt which is obtained by the evaporation of seawater which is collected in shallow puddles over here, and which is also called as shallow lagoons by the heat of the sun. Let us discuss the factors that affect evaporation one by one, and the first factor that we will discuss is about the temperature. The rate of evaporation increases on increasing the temperature of the liquid. In other words, the rate of evaporation of a liquid increases on heating. When the temperature of a liquid is increased by heating it, more particles of liquid, they get more kinetic energy as heat is supplied to it. And when more particles of a liquid get enough kinetic energy to go into vapor state or a gaseous state, this increases the rate of evaporation. Thus, we can say that the rate of evaporation of a liquid can be increased by increasing the heating effect or heating it. The rate of evaporation of a liquid becomes maximum at its boiling point. Now let us discuss about the second factor that affects the evaporation, and it is the surface area of a liquid. Students, the rate of evaporation increases the surface area of the liquid. If there is increase in the surface area, then the rate of evaporation also increases. So if the surface area of a liquid exposed to the air is increased, the rate of evaporation of the liquid also increases. For example, if the same liquid, say water, is kept in a test tube and in the china dish, then the liquid which is kept in china dish will evaporate more rapidly. Why? Because more of its surface area is exposed to air. In our daily life, we spread out the washed wet clothes while drying to increase the surface area for the rapid evaporation of the water which is present in them, and which leads to quickly drying of the wet clothes. After rain, the wet roads, they dry quickly because the rainwater is spread over a large area of the road. This gives the particles of water a greater chance of escaping from the liquid. So from this discussion, we can conclude, students, that the rate of evaporation of a liquid can be increased by increasing the surface area of the liquid. The third factor that affects the evaporation is the humidity of the air. The amount of water vapor which is present in air is represented by the term which is called as humidity. When the amount of water vapor present in the air is less or small, the air appears to be dry, and we say that the humidity is low. On the other hand, when the amount of water vapor in the air is large, then we say that the air appears to be damp, and say that the humidity is high. So the humidity of air tells us the degree of dampness of the air. When the humidity of the air is low, the rate of evaporation is high and water evaporates more readily. Under these conditions, sweat from our body evaporates readily and we feel cool and comfortable. The wet clothes, they dry quickly under the conditions of low humidity of air. When the humidity of air is high, then the rate of evaporation is low and water evaporates very slowly. In the later part of summer, the humidity of the air increases. People sweat a lot in such conditions, in such a weather. But the sweat from our body does not evaporate readily due to high humidity of the air. Such weather becomes muggy or damp and we feel hot and uncomfortable. This type of weather is experienced during cloudy days in the rainy season, as we are experiencing now, and in the areas which are close to the sea or the coastal areas. The wet clothes take a longer time to dry when the humidity of the air is high. Now let us discuss about the fourth and the last factor that affects the evaporation, and that is the wind speed. The rate of evaporation of a liquid increases wind speed. The rate of evaporation of a liquid increases with increasing wind speed. When the speed of the wind increases, the particles of the water vapor move away from the wind, decreasing the amount of water vapor in the surroundings. This increases the rate of evaporation of water. The washed clothes dry more quickly on the windy day because evaporation is faster due to high speed of the wind. Our next topic that we are going to study is the cooling, which is caused by evaporation. Students, you know that we have already studied that whatever the liquid or whenever the liquid evaporates, it must be supplied the latent heat of vaporization. The cooling caused by evaporation is based on the fact that when the liquid evaporates, it draws or it takes the latent heat of vaporization from anything which it touches. By losing heat, this anything gets cooled, whatever it is, it gets cooled. Keeping these points in mind, let us now discuss some of the examples of the cooling which is caused by evaporation. Students, if we put a little of the spirit or the ether or a petrol at the back of our hand and wave it around, the spirit or whatever we have taken, ether or a petrol, it evaporates rapidly and our hand, it feels very cold. What is the reason behind this? This is due to the fact that a change from a liquid to the vapor state. Spirit requires latent heat of vaporization. The spirit takes this heat of vaporization from our hand. The hand loses heat and it gets cool. So this is the example of the cooling which is caused by evaporation. Students, during hot summer days, water is usually kept in an earthen pot. We call it as pitcher, matka, to keep it cool. So let us say how the water in the pitcher, it gets cooled. The earthen pot has a number of tiny and extremely small holes in its walls. Some of the water continuously keeps seeping through these pores to the outside of the pot. The water vapor which changes into vapor, it continuously and takes the latent heat required for the vaporization from the earthen pot, and the remaining water, it becomes cool. In this way, the remaining water loses the heat and it gets cooled. This is also an example of the cooling which is caused by evaporation. We should also note that all the water on the earth does not get evaporated due to high value of the latent heat of vaporization of water. At many places, especially in villages, people often sprinkle water on the ground in front of their house during the hot summer evenings. You might also be doing the same thing. This water evaporates by taking a large latent heat of vaporization from the ground and the surrounding air. By losing heat, the place becomes cool and comfortable. The water vaporizing from the leaves of trees also cools the surrounding air. Perspiration or sweating in our bodies is the body's method of obtaining a constant temperature. On the hot day or after doing some physical exercise, when our body temperature tends to rise too much, our sweat glands give out moisture or sweat on our skin. When this sweat evaporates, it takes the latent heat of vaporization from our body and our body becomes cool. We should wear cotton clothes in hot summer days to keep cool and comfortable. I can also explain this in a better way. Students, we get a lot of sweat on our body in the hot summer days. Now, cotton is a good absorber of water, so it absorbs the sweat from the body and exposes it to the air or to the atmosphere for the evaporation. The evaporation of this sweat, it cools our body. The synthetic clothes made of polyester or any other material other than that cotton do not absorb much of the sweat, so they fail to keep our body cool in summer. A fan increases the rate of evaporation of the sweat from our skin and makes us feel cool and comfortable. The cooling in the desert room cooler is caused by the evaporation of the water. A desert cooler cools better on the hot and dry days. And this is because the higher temperature on the hot day increases the rate of evaporation of the water, and the dryness of air or low humidity of air also increases the rate of evaporation of water. And due to the increased rate of evaporation of water, a desert room cooler cools better on hot and dry days. Students, it is a common observation that we are able to sip hot tea faster from a saucer than from a cup. This can also be explained in this way, that saucer has a large surface area, and due to large surface area of the saucer, the evaporation of hot tea or milk, whatever we have taken from the saucer, is faster. And this faster evaporation cools the hot tea or the milk more quickly, making it convenient for us to drink from it. Now let us see or show the presence of water vapor present in the air. To show the presence of water vapor in the air. There is always some water vapor in the air around us, but we are not able to see it. The amount of water vapor in air keeps on changing. Water vapor comes into the air from the evaporation of the water, which is present in the ponds, the lakes, the rivers, and the oceans. Water vapor is also given out by plants by the process of transpiration or evaporation from the leaves. Animals give out water vapor when they breathe out air. Land also gives water vapor on being warmed by the sun. All these water vapor, where does it go? It goes into the air around us. So we can now describe with an experiment that water vapor is present in the air. The presence of water vapor in the air can be shown by the experiment which is over here. We will take a steel tumbler and put some crushed ice into it. And we are going to wipe this tumbler with a clean dry cloth, so as to make the outer surface completely dry. Allow the ice containing tumbler to stand for some time undisturbed for about 5 minutes. A large number of tiny particles of water, tiny drops of water are found on the outer surface of the steel tumbler. This happens. The air around the steel tumbler, it contains water vapor in it. And when these water vapor come in contact with cold outside surface of the steel tumbler, they condense to form tiny drops of liquid water. So the formation of drops of water on the outside surface of the tumbler containing the crushed ice shows the presence of water vapor which is present in the air. Students, as you know that there are 5 states of matter we have earlier studied. Scientists say that there are actually 5 states of matter: solids, liquids, gases. We have already studied about all the 3. Plasma and Bose-Einstein condensate means 5 states of matter are solid, liquid, gases, plasma and Bose-Einstein condensate. Then plasma. What is plasma? Plasma is a mixture of free electrons and ions. Plasma is considered to be the 4th state of matter. Plasma occurs naturally in the stars and the sun. Inside the stars, the temperature is so high that the atoms they break up. Some of the electrons break away from the atoms, converting the rest of the atoms into electrically charged particles which are called as the ions. This mixture of free electrons and ions in the star, it is called as the plasma, the 4th state of matter. The sun and the other stars, they glow because of the presence of plasma in them. Plasma can also be made on the earth by passing electricity through the gases at low pressure taken in a glass test tube, which is called as the discharge tube. Fluorescent and neon sign bulbs, fluorescent tubes and neon sign bulbs, they form plasma when they are switched on. The fluorescent tube may contain helium gas and a neon sign bulb contains the neon gas. When electricity is passed through a fluorescent tube or a neon sign bulb, the gases which are present in them, they get ionized to form plasma. And this plasma makes the fluorescent tube or the neon sign bulb to glow. Now about the next and the last state of matter, that is the Bose-Einstein condensate. Students, in 1920, an Indian scientist, Satyendranath Bose, he did some calculations for the 5th state of matter. And on the basis of these calculations, another scientist, Albert Einstein, predicted the existence of the new state of matter which is called as Bose-Einstein condensate, BEC. The 5th state of matter called Bose-Einstein condensate was finally achieved by 3 scientists, Cornell, Ketterle and Willman. They were all of USA, And by cooling a gas of extremely low density, means if I am talking about very low density, it might be about 100,000th of the density of the normal air to super low temperatures. So thus we come to the end of our chapter. Now these are some of the questions that you are going to answer. And if you have liked my video, then please do like, share and subscribe for my channel. So thus we come to the end of the topic over here. So bye bye students.